Look, I'm just a geologist. I like rocks. I love rocks.
Hello, everyone, and welcome to the Geology Flannelcast. My name is Steve.
Hey there, everyone. I'm Chris.
Ugh.
No. That's the first time I've ever seen you without your glasses on just now, by the way.
It's weird, isn't it?
It's really weird.
Yeah. It's funny because, I often don't think of myself as a glasses wearer, but I haven't not worn glasses in, 25 years.
Yeah, so probably more than you've not worn glasses.
Yeah.
Yeah.
And it's because I started when I needed, when I was a kid, I had glasses up until about fourth grade, and then I got contacts because it was cool. But man, contacts are just such work.
You got contacts in the fourth grade?
Fourth or fifth grade, something like that, yeah.
Look at you.
Well, welcome everyone to the Geology Flannelcast.
That's Jesse, the blind one.
The premier geology podcast. How's everyone doing today? Thanks for tuning in. We always have action-packed shows here, but we have a very, very timely episode today. There's been a little bit of what's the word I'm looking for? Chaos in the great state of Texas.
I was going to say kerfluffle.
Kerfluffle, yeah.
Yeah.
I kind of blanked there. I don't know. Are you drinking wine right now?
Yeah, what? That's a goblet.
That came out of nowhere. I've never seen this man drink wine ever. I didn't think that he knew what it was.
I was drinking a light beer earlier.
I do have a light beer as well, but
I would hope that's the finest box wine that they make.
No, it's actually pretty nice. My wife went to bed, but there was like this much left in the bottle. I was like, well, I can put a cork in it, or I can just, So, yeah. So you're getting sophisticated, Steve, today.
Oh, well.
Yeah.
So anyway,
strap in.
So we decided the topic of today, we're going to talk about Texas and what's kind of going on right now in Texas, current events in terms of this like really gnarly ice storm that they've been having. And there's been a lot of people without power at the time that we're recording this. Actually, last I heard this morning or so, they're getting people back with power. There were millions of people without power for days and days. And I think now they're down to under 500,000 people without power still, which
is still a huge amount of people.
No, I mean, it's just, you lose power and it's just like, goodbye refrigerated food, heating, and it's,
well, yeah, I think that's more of the bigger issue is heating. So
that's what we're gonna be talking about today, and all this stuff. Actually, I would like to start off with I actually have a bone to pick.
Uh-oh.
And and this is actually great that we're talking about this. So I was watching some of I was visiting some family this week, and I was watching one of with the news stations, the evening programming, I guess you call it like news entertainment, right? And I'm not going to say what station it was. I'm not going to say who the gentleman was, but the first thing on this episode was it was more of a right wing leaning. I guess that doesn't even matter. I shouldn't say that. But the person that was talking was trying to link climate change and say that climate change wasn't happening. And one of the reasons, say, look at Texas. Yeah, what's going on? Where's your global warming? They're getting nailed with an ice storm, and try to say that was climate. And immediately, so I just wanted to. I've said this on the show before, but you can't blame one single storm and say that that's climate. The definition of climate is decades at the minimum. I think like 40, 50 years of
30.
It's 30. We talked about the
rule is 30 years.
30. Okay. 30 years of weather data in order to even start. And that's at the minimum to even start throwing that word climate around. And you can't say just because of one single storm that and link that to climate or climate change.
So I'll talk about this a little bit, I guess, when we really get into it. We would consider this a weather event.
Mm-hmm.
Yes.
You wouldn't consider a climate event. You won't say it's a climate event.
No, I think I've talked about this on the podcast too. I've gone out to, clients or I investigate all kinds of environmental releases in the area.
They're going to just say, I investigate all sorts of weird things. Like,
So that's where I thought he was going, like
No.
Ghostbusters or something like that, you know?
No.
you wear like French coat and just walk the streets at night to fight.
Do you have any ghouls or specters? No, but I was at this gentleman's house. Their heating fuel tank leaked, and I chit chat with the person, and he was saying that he was from the Western Pennsylvania between Pittsburgh and Erie. And I said, oh, well, I used to vacation in Erie all the time. And we were talking. And then somehow it like took a hard turn. He's like, well, you'll never, no one, anyone ever says will ever convince me that there's climate change. And I was just like
fuel oil.
I was just like, I'm sorry, what? Like, he's like, yeah, like nobody. And so I immediately, we weren't even really talking about climate change. It was like a nice day or something. I think I brought up. And then, so I slowly turned the topic to like Erie, and we were talking about fishing and all this stuff. And I was like, yeah. And isn't it interesting how like, people in Erie used to get all kinds of lake effect snow in November, like, tons and tons of snow. He's like, yeah, man, I remember when I was a kid, I used to get tons of snow. And I was like, but then the lake would freeze over, and then they'd stop getting lake effect snow because the lake froze over. I was like, now the lake never freezes over. So they just keep constantly getting dumped on and dumped on and dumped on. And they keep getting more and more snowfall events. And he was like, oh yeah. Like, it's like sometimes you have to like take it home a little bit, like give them a little bit of a perspective of like, yes, when you were a kid, used to be a ton of snow until the lake froze, and then the lake froze, and then people stopped getting snow because there was no source of water.
Couldn't evaporate.
Yeah. So I guess just, yes, that was my experience with like weather versus climate, and trying to explain it to somebody over a longer term.
And you get atmospheric disturbances that can affect, for a short period or a long period. This would be sort of a short period disturbance, what we're seeing in the South. And it's an atmospheric disturbance, that's what it is. Or you get a long term, a little bit longer, like Mount Pinatubo. Which created which created the conditions that cooled the planet just a little bit.
So we couldn't swim.
And so I couldn't swim that summer. So
I hope good friend of the show Ryan is listening.
Yeah. So
what year was that? 90?
So we're 93.
Erupted in 91.
91. Okay.
92.
So it was 92.
Yeah.
Oh, 92. Okay.
Yeah, because it was June. I didn't realize this until recently. It erupted, and I'm not saying it's a coincidence or this is the reason I remember it, but it erupted in 1991, the day after my birthday.
Mm.
It erupted in June 15th of 91. And so the disturbance lasted until the next year. But you wouldn't consider that sort of a climate.
No.
It was just to be a long-term atmospheric disturbance.
Not unless Pinatubo erupted for 30 straight years.
Yeah. There was just a quick side note, and this is what I mentioned earlier before the show. So a side story about Pinatubo. I don't know if you all noticed, there was a mouse that they just rediscovered on Pinatubo. The classic Pinatubo volcano mouse. Apmis scarabaeanus. I think I don't know if I'm pronouncing it right. It's a little cute little guy. Tiny, long tail. Looks like a mouse.
Mouse that looks like a mouse.
Mouse looks like a mouse. I'm a regular.
All right.
You're a biologist over there.
Yeah, regular biologist. So it was home to this mouse. The mouse only lived on Pinatubo, hence why they called it the Pinatubo volcano mouse. And it only lived near the summit in the sort of the upper reaches of the mountain. And so when Pinatubo erupted in 91, it was a massive sort of cataclysmic eruption. It lost, the top 1,000 feet of the mountain vaporized, essentially, were exploded off.
Ooh.
and it the hole it left in the ground was a 1.5 mile wide hole, and it obliterated the pyroclastic flows down the side of the mountain, just killed the forests, and you had some lahars that came down the stream valleys, and most ecologists thought,
Well,
they had a good run, and they hadn't seen it since, and they've only just rediscovered. They made it. He made it.
No kidding.
They made it. He and she, the mice made it. So
Life always finds a way.
the Pinatubo volcano mouse survives, and
that's amazing.
yeah, and it's it's sort of it's these little critters. It made me think of mammals after the Chicxulub impact.
Ah,
Yeah.
yeah.
Little tiny sort of mammals that live in maybe little burrows, find a way to survive these cataclysms.
See, that would be climate change, the Chicxulub impact.
Yeah, that lasted for
Yeah.
a little bit.
Yeah. Speaking of the Chicxulub impact, again, to get off on another tangent, I saw an article recently that someone's trying to claim that it was a comet, not an asteroid.
Yeah. Did you send that link out?
I did, and
I didn't read it.
I read it, and they're like, yeah, well, it could have been a comet based on the math. It's like a much less likely scenario that it was a comet. And then all the other scientists are like, well, what about all the iridium? Like, where did that come from? So,
Good point.
I haven't dove deep into the
So you don't get iridium. The metal is
Yes.
only on the meteorites.
yeah. So iridium is a element on the periodic table that's mostly found in asteroids. It's more abundantly found in asteroids than it is on terrestrial planets. So, and comets are mostly made of ice. So if a comet,
Big all snowballs.
yeah. So if a comet hit the planet, it would still be devastating, but there wouldn't be this dusting of iridium all over the planet. So I don't know. I got to dive more into some of their sources and things like that. But anyway, that was just a little sidebar. I just saw that today. So
Yeah.
don't believe it.
That's
Don't believe the hype.
Actually, so I'm thinking about this and that Chicxulub impact. I want to say I'd like to challenge that idea about it causing climate change, because how long did it change the climate?
More than 30 years, buddy.
It changed the climate because it
Yes.
okay.
Think about it. It burned like, how many percent of the forest across the entire globe?
Yeah, so
Okay. I see. Okay. I'm
Yeah.
sorry. I was thinking different minds. Okay.
Right.
No, yes. Did the initial impact and all that stuff?
That's what I was thinking. Yeah. It's like,
Yeah.
clouds the earth for what they say, 2 years or whatever.
yeah, that's kind of interesting, and I think we should just mention that real quick. So the idea, and this was sort of the idea about a nuclear winter, right? It became big. I think Carl Sagan first posited this, where if you drop enough nuclear bombs, it kicks up so much dust into the atmosphere that it blocks sunlight and cools the planet off. And that was the thought here, where the asteroid hit, it kicked so much dust up, it blocked sunlight out. And I think early on, researchers and folks thought it cooled off the planet and sort of made this nuclear winter scenario. But now we're finding, like, the way the atmosphere works and the way rainfall works, it really would only affect the planet for, like you said, like 2 years. It's sort of, no matter how cataclysmic it is and how much dust it kicks up, it comes out pretty quickly.
I mean, well, yeah, relatively pretty quickly. 2 years without sun would suck.
Yeah. Oh, yeah. It caused an extinction event.
Yeah, yeah.
Essentially
Yeah.
because of that. But from the, it's not a hard and fast, 30 years, but it's a longer term. And that's, the friend of the show, Maddie here, just asked, is it climate change if it totally resets the climate? Yeah. Cause your climate is climate is what's happening. And so if it shifts or if it changes in any way, there is no resetting because there's no starting point. It's always moving. Climate is always changing to a certain extent.
Sorry, I wanted to bust into the "What's Happening" song. Wow, 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 wow. Sorry,
But
again, I've been aging myself left and right today. What's Happening was a popular show in the 70s and 80s, but carry on.
but yeah, it's just climate is something that's it's always going on. Is there a show called No? So there is no idea about it resetting. You're just altering it over time.
Yeah, and if it's altered for more than 30 years, then it is a change in the climate.
And part of this is the one thing I always say is climate it's always changing, and it's always sort of shifting, and it's been warmer and it's been colder. The reason we sort of focus on it now is because we as humans have never experienced, to a certain extent, a shift like we're going, or the change we're experiencing now, at the rate that we're experiencing. And
yes.
So I think that's part of the issue here.
Yeah. So, humans have been evolving for the last, 2 million years or so, up until, Homo sapiens. But so for the last 20,000 years or so, we've been coming out of an ice age, evolving as we're evolving. So for the last 20,000 years, yes, things have been getting warmer, but now they're getting warmer on a pace that's unprecedented.
Yeah.
And again, when I say getting warmer, that doesn't mean every single part of the planet is getting hotter all at the same time. I mean, yes, I guess generally, if you take a whole big average temperature of the planet over the year, yes, but
it's and so Homo sapien, like modern humans, we've only been here. I consider myself a modern human. Y'all are in the same boat.
Wow.
To anywhere from 100 to 200,000 years. Like, modern humans have not been around long.
Mm-hmm.
And the last time we've experienced warming like we're in now was 125,000 years ago. It was what we call good old, as everyone knows, marine isotope stage 5E.
yeah,
Rolls right off the tongue.
So good.
here's the 5E.
Yeah, it's the last major interglacial, as we call it, because we've been bouncing between glaciations and interglacials. So these warming and cooling for the past 2 million years. The Pleistocene is denoted by these advances and retreats of glaciations.
So interesting. I was just I didn't realize this yet. I guess this just came out actually last month. But 2020 is tied for the warmest year on record.
Yeah, 2017?
16, yeah.
2016.
And it's the first, it was 2020. 2020 is the first non-El Nino year to take that title, I think.
Oh, is it?
Woo. Good job, 2020. Made the record books or something else too.
Yeah. So so going from great, the hottest years on record, it was 2020 and 2016, and then 2019, 15, 17, 18, 14, 2010, 2013, 2005, 2009. 98's not on there. 2009's at I guess 10th or 11th place now. But yeah. So some of these numbers, we're looking at just in those top 10. I said 11 years. I added on 2020 onto there, but we're looking at 15 years of of the warmest. I guess what I'm trying to say is it looks like regardless, we're getting closer to that 30-year mark, that we said for the definition of climate. So,
oh yeah,
this is an ongoing thing that's,
kind of crazy,
getting warmer and warmer. And then if you just look at, I'm looking at some charts here about just kind of the warming, and you really kind of see this spike from into the 1980s. The warming really starts to take up, and it kind of starts to follow an exponential curve, really increasing from the 80s, 90s, early 2000s, early 2000s, and then the teens. So it's there's, I don't know. Things are getting warmer.
And then based on these trends, you get exacerbated climate, meaning and exacerbated weather. So you're going to have more intense, more frequent weather events. So you're going to have more intense, more frequent hurricanes.
Yeah. Did we talk about?
We did talk about it, like how it's basically ocean temperature dictates hurricanes, and then how much water can be.
Did we do my fun fact of? I don't know if it's a fun fact.
It's gonna be
of from like 19. I don't know. I'm, don't cite me on this. Fact check it for yourself, but from 1950 to 2000, there were essentially like 60 category 4 and 5 storms. And from 2000 to 2020,
yes,
65 category 4 and 5. There's been the same amount in half the time.
We've definitely talked about it. I don't know if it was in a Patreon extra or one of our podcasts.
I think we talked about it in the podcast. Yeah.
Something like that, which, that's a function of, and it's kind of interesting, because the old thought was, warm water leads to hurricanes. We should expect more hurricanes. But what we're actually seeing is that warm water leads to more intense hurricanes.
Yeah. And not just, and by intense, not necessarily the severe Simpson scale is what we use to categorize hurricanes currently. And it has to do with wind speed. And because back in the day, wind speed was the most devastating factor. Well, now the fact that the ocean has so much essentially potential energy with the warm water getting evaporated, now the biggest deadly factor of a hurricane is getting to be the amount of water that's dropped.
Yeah.
So the potential for it to hold more water because the air is warmer, the water is warmer, is leading to more devastation.
And warm water causes water to expand, which is sea level rise, and warming.
Yeah, that's the one that a lot of people don't realize attributes to sea level rise. Is just the expansion of the oceans due to heating it up.
And so when these hurricanes move on shore, they, sea level rise is part of the reason flooding has been so bad with some of these recent storms. But you look at Hurricane Harvey that came ashore near Houston a couple of years ago.
Oh man,
it dumped like 40 inches of rain.
It was something ridiculous, like trillions of gallons of water in like 48 hours or something.
Yeah, and when it made landfall, I don't think it was that strong of a storm. I might be wrong here.
No, it was still, I believe it was still a hurricane, but it wasn't like a category 5 or anything like that, but it was a hurricane. But after a certain point, you don't even care about how bad the wind speed was when you're dumping 1 trillion gallons of water onto, like, it was so much water that the USGS could actually measure, like the ground was depressed because of all the water that was dumped on it. The topography actually got lowered because of all the water.
There's it made landfall as a category 4, so it was still powerful.
never mind.
Yeah, but it's interesting. In Australia a couple of years ago, they got hit by a bunch of severe floods because they get right when they move. I want to say it's right in the shoulder. either when they're coming out of winter or going into winter.
Yeah, they're all backwards down there.
Yeah, I'm sorry, I'm all turned around. Is when they get their stormy season, when they get their wet season, essentially. They have a funny name for it. Those crazy Aussies. Bangarang, maybe, something like that.
Banger.
That sounds about right.
Yeah.
That's a Skrillex song. That's not a
Yeah.
Skrillex.
Now, what is... Yeah. Oh, boy. It's going to sort of bother me. It's something goofy like that. Anyway, they got so much rain, they caused flooding in the interior of the continent, that there was a noticeable drop in sea level rise in the Eastern Pacific and Indian Ocean basins, because that water had been dumped on the continent.
Jeez.
It took...
So the rebound was taking so long.
Yeah, it took time for the water then to recede back into the oceans, that it was measurable.
Wow.
In terms of, that's
incredible.
There was a paper a couple of years ago about that. And it just sort of blew my mind that there was so much water dumped
on Australia that it acted like a sponge.
Yeah.
Yeah. And that's, that was one of my first like environmental science kind of labs to do back in high school in the mid 90s, if you can believe that, like, was to measure stream water recharge. A storm comes in, and if you have enough pervious surface, essentially places for the water to infiltrate, then the creeks should actually peak after the rain stops. But if you have impervious surfaces, then the creeks actually peak, during the rain event. So essentially Australia acted as if it was a giant impervious surface, essentially a sponge holding on to all that water. That's insane. enough to change sea level is crazy.
Wow.
Bangarang.
Bangarang?
Yeah.
Bangarang.
Not it's an RENG.
I thought that was an Australian minivan, but
I think that might be, I don't know. I might be off. Anyway, it doesn't matter. The thing is that to get us back sort of full circle here with Texas.
Yeah.
Yeah. Took a little detour, but back to Texas.
A cold
background information,
I don't want to take anything away from it, but it's a cold, I don't want to call it snap, but a cold period in the center of the United States for days on end does not equate no global warming.
No, and I think that's part of it, is that it's sort of a paradox, because it's likely caused by warming. So you get warm as you warm the atmosphere. Some of this warm air gets pushed aloft into the stratosphere, which is, tens of miles into the atmosphere. Normally, where you have really cold air, and so when you push this warmer air aloft, it actually diverts the cold air down. And so that's if you've ever heard the term a polar vortex.
Mm-hmm.
That's what's happening here, is you have this warm air in the Arctic that's getting pushed aloft, and what's known as the jet stream, which is stratospheric, this sort of river of air that moves around in the stratosphere. Or I guess it's part of the troposphere and stratosphere. And it's cold because it's at elevation. It's at height, 5, 10, 20, 30, 40 miles in the atmosphere. And when you push this warmer air up, it disrupts that flow and actually causes it to drive down to the surface. And it usually causes it to drive down the surface. The jet stream it comes from the Arctic, like across North America, down up over the Rockies, and normally shoots across the Midwest and, up, and then shoots back up into the North Atlantic. Well, if you sort of disrupt that, you can cause it to drive down into the near the surface, and that's basically what's happened. A couple of years ago, the same thing happened, but it happened in the northeast of the U.S.
Yeah, I remember I was working outside.
Yeah,
all winter. It sucked.
Yeah, we had like -30 for like a week straight or something.
Yeah, I remember. That was 4 or 5 years ago, and as a kid, I remember like the Delaware River freezing, and I don't remember it freezing ever for like a good 20-30 years, and then until I had to work outside.
Yeah.
Then I remember it. Yeah, like I could walk to New Jersey over the river.
That's essentially what's going on, sort of in the lower states right now, in the Midwest into the South.
Yeah,
there's this disruption of the jet stream.
As I saw a meme the other day. It was this weather pattern. It was like really hot on the West Coast and really hot on the East Coast, and like just blue and purple in the center of the country. And it's like, they call this the 7-Eleven burrito weather pattern. It was like lava on the outside and frozen in the middle.
But it's kind of crazy because we've here in the Northeast, we've gotten hit with 2 snowstorms now back to back in a week.
Yeah. Because last year, I think we got like a dusting.
Yeah, the past 2 years we've had 3, and now we got it. It's also sort of crazy, some of these storms, because the one last week where we got like over a foot, it was the weirdest storm I ever remember. It was like sleet and then snow and then sleet and then snow. It was weird. But we got 9.5 inches, and literally in the town next to us, which is less than a mile away, they got 4.
Yeah.
Doesn't make any sense.
And it's interesting, we're getting a little bit off topic, but they often talk about that I-95 corridor for anybody who lives on the East Coast. The storm's going to follow the I-95 corridor. Well, there's lots of there's an engineering reason why that happens. There's a geological reason why that happens. The engineering reason is
is that where the cities are?
Yeah, exactly. The I-95 corridor follows the cities, and the cities geologically follow the fall line, essentially.
Yeah.
So where the Piedmont ends, cities back in colonial times established where ships could get to. Well, ships can't go up waterfalls, so the cities kind of stopped where the waterfalls happened.
Mm-hmm.
And the fall line is essentially where the I-95 corridor is, because the I-95 corridor followed that fall line where those waterfalls were, all the way up and down the East Coast. And that topographic change also affects the weather. So if you're on the one side of the I-95 corridor, you might get that wintry mix or rain. And if you're on the other side of that I-95 corridor, essentially up topographically a tiny bit, you're going to get snow. And that's why that line often follows that I-95.
And also, so the fall line happens because that's pretty much where the coastal plain hits Piedmont.
Yes.
You start hitting this like the crystalline rock, and kind of the coastal plains just all just flat lying, unconsolidated sediment.
Yeah, and we could totally get into Jesse's realm, like with the history of and the fall lines and industrialization, and using those fall lines to power mills and power like all kinds of stuff. Yeah.
But when you have on the East Coast, you have storms that are called nor'easters, and so these are storms. And actually, Semenek knows, he could talk about the Black Friday storm.
Ash Wednesday, you mean?
Wednesday.
March of 1962? Come on.
I got my wrong Catholic holidays there. But these storms roll up the East Coast, and they're called nor'easters because they're rotating counterclockwise. So the wind is blowing from the northeast as it hits the coast. And this is part of it, is where you have that fall line, as that air mass is coming across the coast, it's dumping the precipitation or whatever. And if the air is not cold enough, it's going to come out as rain or as sleet. But as that air mass starts hitting elevation, the air mass has to go up. And as it goes up, it cools off. And so then it drops the precipitation as snow or ice. But so it's, it is sort of interesting when you piece together how the geology affects this weather patterns. And so it's, whenever you look at like rain shadows, never cease to amaze me.
Oh yeah, they're pretty crazy. And it's so rain shadows are when so you see that it's this area we have mountains, these tall mountains, and and then just on the other side of the mountains you get into this desert environment. And it's just, you see, because all the precipitation kind of occurs in the mountains, and there's nothing happening. Like, so on the right next to the mountain. So you see this in the United States,
East
basically
Coast. The east side of
the east side. I was going to say the East Coast is not a rain shadow. Yeah, just to the east of these mountains, you see that's the rain shadow. You get these desert environments.
Picture the Pacific Northwest, like picture Washington or
Oregon.
Yeah, picture like Seattle. What do you picture in your mind? Like, it's always raining, and you have these temperate rainforests. But the eastern side of Washington State and Oregon are deserts. And it's because the Cascade Mountains there. So all of that air mass, as the air mass has to go up and over the Cascade, it just drops all of its precipitation because it's cooling as it's going over the mountain.
Yeah, that's what our Patreon Maddie just said. Excellent example. East side of Oregon, high desert, western side of Oregon gets 9 months of rain.
Yeah.
It's a lot of rain.
Nonstop. Anyhow.
Speaking of rain, have you ever had rain on a Word document before?
No.
You've never lived. This might qualify as the worst segue ever.
That didn't even make sense. Like, are you talking about like precipitation or like the rain, like REIGN?
I don't know. I was thinking purple rain, like Prince.
Which rain are you looking for? Do you know how to find the thesaurus?
Oh, there you go. See,
there we go. See, we just fixed that. Jesse just fixed that.
He did. So the formatting formula, formattingformula.com or YouTube/C/formatting formula. Jesse did just mention the thesaurus, which is a very handy tool. You don't know how many times. If you ever had to write like a cover letter or a statement of goals or something like that, and you want to sound smart, but you don't want to repeat yourself, man, that thesaurus on Word is very, very valuable. But the formatting formula not only can show you how to use the thesaurus, they can show you all kinds of different things, like formatting your table of contents, formatting your they can actually create fillable documents and things like that. So, if you have something that you have to fill out over and over and over again, they can create documents where you just like fill in here, like the date, the name, the site or whatever. They can teach you how to do all that stuff at YouTube/C/formatting formula, where they have all kinds of videos for all different all different versions of Word for Mac and or PC. So check them out, formattingformula.com. But more important than that, check them out on YouTube, like them, subscribe to them, but then write them a comment. Say, Geology Flannelcast sent me your way. So they know who to thank for that. So check them out, formattingformula.com. Tell them Geology Flannelcast sent you.
So I guess back to Texas. I know they were having, I think you guys wanted to talk about this. You're saying about the power outages.
Yes.
Right? And what was going on with that? And I don't know. Jesse, did you have some stuff you wanted to talk about that with in terms of the windmills?
Oh boy, do I.
Here we go. This is good.
I'm a regular Don Quixote here.
Donkey what?
Yeah, just going. I guess I would be Sancho Panza, maybe. I don't know. Look at these literary references I'm drawing.
I'm blown away.
So this topic was mentioned to me by a fan of the show, my friend Carrie, who lives down in Texas and was without power, and basically wanted to know why am I without power?
Spent the last of their phone battery life to text you to say, why am I without power?
Texted the old Geology Flannelcast helpline.
I could call the power company or Jesse. I'll pick Jesse.
And you know what? They made a good call.
Yeah. It'd be like, oh, I'm glad you asked. We're recording late this week, so you got to wait 2 extra days.
Yeah, you only get a Don Quixote reference in a Premier Geology podcast, which is what our Patreon Maddie said.
Why we are the Premier Geology podcast, but continue.
So I guess sort of the easy answer is because they were unprepared for this storm. So Texas is sort of interesting, and I'll oversimplify a lot of this, but the way our country is set up in terms of its power grid, and feel free to jump in if I mess this up, is basically our country is divided into 3 regions when it comes to the way the power grid is set up. There's the Eastern grid, which covers basically all of the Eastern states into like the Midwest. And then there's the Western grid, which is sort of the Western states, including the Rocky Mountain states. And then there's Texas.
Then there's Texas, baby.
Texas is its own grid, and a lot of it comes down, I don't want to simplify again, but to the mentality of we can do this on our own.
Yeah,
Texas is a very big state, I will say. Like,
Texas is a huge state. Texas has been extremely independent ever since it's been a part of the United States. Texas has tried to secede before. Texas has been part of Mexico before. Like Texas,
they were an independent country for, I don't know, it doesn't matter, a few.
Yeah. So
Texas. Sorry to our Texan listeners. I don't recognize any of that.
No, but
not really.
They are a very proud state. They are a very independent state, and they also produce a ton of energy.
They do
a ton. And
when you think of geology in Texas, what do you think of?
Exactly, oil and gas,
black gold.
They produce a ton of energy.
Literally Texas tea.
Yeah, other than like, West Virginia, Pennsylvania, and Kentucky producing coal, maybe Ohio, like Texas,
Wyoming, Montana. Let's not.
Well, yeah, Wyoming, Montana. Texas is where it's at. So Texas, based on this, again, I'm oversimplifying too. Based on this historical thought of we can be independent, decided we don't need the federal government overseeing our electrical grid. We're going to do it ourselves. And they established this own independent electrical grid overseer, essentially, to oversee the Texas electrical grid.
And part of it was there was a lot of this came in the 80s when energy in our country was deregulated by the federal government. And so they were allowed to sort of do their own thing, and they established the Energy Reliability Company of Texas, which is a nonprofit agency that oversees all of the power and oversees the grid. I do want to mention part of the reason I like to give Texas a lot of guff is just because it riles up Texans so much. And, my friends from Texas riles them up, and I just love it. But you said Texas is where it's happening, and that's something that no one outside of Texas ever says.
Well, if you're from Texas and you're listening to us and you want to have a voice on this podcast, become a Patreon.
Yeah.
Check us out on Patreon.
You can join and give me all the guff you want to give.
Exactly. If you join Patreon, you get to suggest episodes. You get to,
I say this all half tongue in cheek.
I have no tongue in no cheek. I'm saying become a Patreon. Put your money where your mouth is, Texas.
Yeah.
Go.
Yeah, I'm messing with Texas right now.
Oh, nobody messes with Texas.
Oh man,
I shouldn't.
that's gonna be a mistake.
Yeah.
All right.
Yeah. So back to what's happening.
Well,
So-
real fast. So just about the
You said
wind
what's
energy.
happening again.
I know. Turns out Texas is where it's happening.
So Texas is the largest wind producer of the largest producer of wind energy, excuse me, in the United States.
There's a big difference between the two.
So they make let's see, they're making a ton of wind energy, and if Texas were to become its own independent country, it would be the 5th largest wind power producer in the world.
Nice.
So
And so with these power outages, 80% of the outages are due to oil and gas. Actually, gas and oil, essentially. Gas and coal. Wind turbines that shut down account for less than 15% of the power outages. And those turbines that shut down because, well, they froze. It got really cold. And so you need to account for cold with anything in life, and you need to winterize. So turbines you can winterize, fairly readily. You think about
there's
upper
wind
Midwest.
turbines, all throughout North Dakota, South Dakota, Wyoming, like all throughout the Midwest. There's tons and tons and tons of wind turbines, and they don't just stop in October.
Yeah, there's wind turbines on Antarctica.
Yeah.
That's one of the ways they power McMurdo. So you winterize them. Basically, you put little heaters up in the generator to sort of keep things moving. And you gotta account for like how you grease your gears and whatnot. And they didn't, because this is sort of a one-off storm. They weren't.
yeah.
No, and exactly that makes sense. Like, why would you winterize something that's
And it's
never been below freezing before?
It's interesting too, because there is so much wind power in Texas. The turbines that weren't knocked offline could generate enough excess power to essentially account for the ones that were knocked offline. So the real issue here comes from the natural gas, which is sort of interesting, in that in Texas and in a lot of places, the natural gas where you have the natural gas power plant, there's very little storage.
Okay.
And so the natural gas storage is coming from the Permian Basin of Texas. So the Permian Basin is in West Texas.
I believe so, but
yeah. So the Permian Basin is in the western and southwestern portions of the state, near like the New Mexico border. And so you have there, that's where a lot of your oil came from. And so when you pump out oil, you pump out natural gas as well. And a lot of that natural gas they used to just flare, they would burn. So, but a lot of the older oil fields where they've sort of spent the fields and they've exhausted them, you have space now. And so what you do is you pump any natural gas you're producing into that field, and it acts as a storage basin. You're using the natural reservoir. And we do this in Pennsylvania. We have a ton of old oil fields in Pennsylvania. And that's the main place we store our natural gas that we produce, say, through fracking. Is it gets fracked and it gets pumped out of the Marcellus Shale, and it gets stored in these fields in Western Pennsylvania. And a friend of I only sort of realized this very recently, more recently than I care to admit. Like December when I was talking to my friend of the podcast, Liz, who works for the state, and she maps abandoned oil and gas wells, and she deals with the oil fields. And she texted me and she was like, all of our fields are topped up with natural gas ready for winter, because that's where they store all of the natural gas to then pump to the power plants to produce throughout the winter when it's needed.
Yeah, there are caves and stuff in southeastern Pennsylvania, down here in Delco, that they actually, like, there's like equipment in there. There's like trucks and stuff in these caves, but the caves were so big that they just sealed them off and used them as essentially storage tanks
it's
for
crazy.
natural gas.
Wow. Jesse, if it makes you feel any better, I didn't know that's where they stored natural gas. So I'm just learning that now in February.
I was like, oh, that makes a lot of sense. So in Texas, they store a lot of the natural gas because they frack down there and they pump up. I mean, anywhere you have oil, you're going to have natural gas. They produce together. And so the problem is all of their population centers are not in Western Texas. And so so your power plants are near your population centers, because you lose energy on transmission lines. So you want to have your power plants near your population center. So they're shipping this oil across. And so what's happening is you're getting freeze up along pipelines. And so it's the transmission of, or the production, it's just trying to move the fuel source. It was these pipelines and the power plants themselves are not equipped to handle cold, because again, one off. Like
and this is totally anecdotal, but my parents and grandparents grew up in the northwestern portion of Pennsylvania, where there's a lot of natural gas just naturally in the ground, and you could purchase a house and it would say like free natural gas heat. And I remember asking, like, what are they talking about? They're like, oh yeah, well, there's just natural gas in the ground. You just stick a pipe in the ground.
Just have a pipe. Yeah. Just
and
oh my gosh.
And in the summertime, when the ground is warm, there's a lot of pressure on the natural gas, and you'd have a lot of pressure on your stove. You'd turn your stove on, your flame would be 10 feet high. And I think I've talked about this on the podcast before, but when it's really, really cold out, you turn your stove on and the pressure is lower. So you'd only have like a 2-inch flame on your stove. And I'm wondering if that's the same thing with these Permian Basin stuff. Like, if you cool that down a few degrees, I'm sure the pressure differential changes. And this is totally guessing. This is totally anecdotal. I don't know if that's really
well, I'm sorry, Steve, what causes the pressure differential? What were you saying?
The temperature. So what's the ground temperature?
Yeah, but the ground temperature stays pretty constant. That's why like only like the top couple
not really. I mean,
but like the only like you would only get like if there's like the top of the ground freezes from storm, like only the top couple inches freezes. And
it's up north, up north, like in northern Pennsylvania. Your frost line is like 5 feet.
I was gonna say it's 48 inches, I think.
Yeah. So it's if you're getting gas from
48 inches.
Yeah.
Wow.
Yeah. And that's why like there's building codes and stuff like when I built my deck, I had to dig down 40 inches to put my footers.
Yeah, I was gonna say I thought it was
to get below the frost line.
Inches in Philadelphia, yeah, because you got to go to the frost line.
Yeah,
but even the temperature, the temperature difference before you hit like where you lose the surface is like 50 feet before you hit like an average temperature of like 50 degrees.
Okay,
and so. It's not saying it's freezing, but it's enough that that temperature differentials matter to a certain extent. But this has to do in Texas. It's just the pipelines aren't winterized. Like when we had the polar vortex, like we didn't lose power at all.
because we can handle.
because
The cold.
we know.
So you're saying we're better than Texas?
I didn't say
I think he's messing with Texas right now.
I'm not saying it. I'm just throwing facts out.
So
I'm saying
something about the Cowboys.
But it's just it's just and part of it, like, some of it you can't plan for it, but on the other hand, you should start thinking about these things, because these extreme events that we're seeing are in some part caused by disruptions in the atmosphere. We've seen more polar vortexes in the past 20 years than we had in the past 50.
Right.
And whether or not that's just a coincidence is I guess subject to a little debate. Part of Texas too, ERCOT, and so the company or the nonprofit or whatever, the agency that runs it, they had taken some plants offline for just maintenance because they weren't.
So it's just bad timing.
It was that was a small part of it, but it was just a lot of the natural gas and the coal, and to a smaller extent nuclear power. They had taken some of the capacity offline, but none of it comes down. Long story short, none of it comes down to the wind power.
Or a very small part. If they were part of the national grid, this may or may not have been a thing.
Issue. It would have been. I don't know if it would have been so long lasting.
True. Yes. I agreed. Like just with any storm, any sort of outage, you may have a local.
Missouri and Arkansas are dealing with these issues right now, but
right. But you can deal with a power outage for 12 hours. It's hard to deal with a power outage for 5 days.
Yeah. I remember we lost power a couple of years ago for like 4 days, and it was just a headache. But that was
in the summer though.
It was ice that it brought down lines.
Oh, it was ice.
Yeah, it was like a March storm. So March storms just are ice because it's like warm enough.
Yeah.
That it's not snow. So it was ice. Yeah, it brought down all the lines. Real bummer. One of the other things they're dealing with is that very few of the homes are insulated.
Yeah, sure.
And so like pipes are bursting left and right.
Jeez. Yeah.
So like these water, all of the water plants are just trying to manage this.
They can't, like, imagine everybody just turn on their faucet all at once because your pipes burst. The water companies can't handle that sort of supply.
They just said it's just sort of a mess right now with trying to like get pressure back up and trying to figure out where things are broken in, and like people don't know how to turn off their water in their house. I don't know. Growing up, we would have pipes that would break when they would freeze. And so maybe it was just me. But
no. I agree. Like I know where to turn off the water. I know where to turn off the gas. I know where to turn off the gas inside. I know where to turn off the gas outside.
It's good things to know when you own a house.
I mean, I know where to turn the water off outside. There's a special tool though you need to do that, and I don't have that. But
you know where to turn it off inside?
Yeah.
Okay.
Yeah. It's a very old ball valve, which when I turn it off, drips a tiny bit.
Mine got replaced with just a regular valve,
like a quarter turn valve.
Yeah, and every time I do it, it's just like everything shakes. It's like the scene from the shaking the pipes.
Yeah,
but we do. Yeah, I remember we have the thing out on the street.
Right.
The front of my house is a little hill that has a tree on it, and I have no idea where it is now, because like the soil has creeped over it.
No, I know where mine is, but I don't have the tool to turn it off. Yeah. I'm sure I could get in there with like a wrench or something, but yeah.
So anyway, Texas, it's sort of like everything that could go wrong has gone wrong.
Yeah, I don't know if you and again, I don't want to get too political, but I don't know if you saw the I think it was the mayor of Colorado City, Texas.
Oh yeah, he resigned after that.
Oh, did he?
Yeah.
Okay. He basically said, "Suck it up, figure it out for yourself."
Yeah, you're on your own.
Yeah, you're on your own. Stop looking for a handout.
The point of the government's not to help you. And people are like, no, actually it is.
Yeah, it was pretty bad. But
well, the good news is the weather forecast, at least in Dallas, is looking like it's heating up. So
yeah, it was through this week it was cold. Yeah, it's supposed to get warmer. If you are in Texas, the Texas Tribune has just done a phenomenal job reporting on this. And if you want to read up on any of this, the Texas Tribune is where I've got most of my news on this.
Yeah, and I went so the Texas Tribune and maybe the Austin Times, maybe
There.
But
support your local news. Again,
our heart goes out to you. We're not wishing ill will, but at the same time, they're this is just what climate change can lead to weather changes.
Yeah,
these sort of ran these extreme events, and that's
lots.
And again, it's all tongue in cheek, and hopefully when everything's back to normal, I'll still make fun of Texas
and honestly, but in all seriousness, like people died, over 40 people died. Like this is terrible. There was a pier collapse of like a floating home community in Louisiana. Like it's not just Texas that's being affected by this weather, but Texas was affected by the weather in that they lost a lot of power. And because Texas decided to regulate their own power. And but that's not to say that the weather hasn't affected other parts of the Midwest.
No, and part of there is part of a story here, and it's not a story for us to sort of get into, that none of this to a certain extent is like a surprise. There is a story about, like, people have been saying, like, your system is not ready to handle X, Y, and Z.
Mm-hmm.
And they just sort of ignored some of the
kick the can down the road.
Yeah, and you can say that about any state in the union.
Yeah, the whole United States with our infrastructure.
Government doesn't tend to be proactive about many things.
No, and it's a case where when bad things happen, it's easy to look at that and say, people have been saying this for years now.
Yeah. I mean, most developed nations have had high speed internet to like 95% of their community for decades. The United States does not.
I just got it last year.
Like we have high speed internet, yes, to a lot of the industrialized, urbanized areas, but there's still a lot of the United States that, use dial-up or satellite or whatever, and I guess satellite's technically high speed, but there's a lot of infrastructure things that are going on in the whole United States, not just the Texas electrical grid. So.
Yeah.
Anyhow.
Well,
yeah. Sorry. I went on a dark turn.
No. So there you have it. So, just because you get one cold snap in Texas doesn't mean climate change is all, disproven. No, it's stuff like this is going to happen. So, I hope they, start getting things cleared up there. I heard about the giant, on the interstate. How many cars were involved in that pileup? It was like there was like a ton. It was a huge auto accident.
You always see, like, when the South gets like an ice storm, you see scenes of the highway where it's just like hundreds of cars and.
I remember.
I feel like
Georgia had an ice storm not too long ago, and the whole state shut down for like 3 days.
Well,
I would like to say not that we're any better at driving in like snow or ice. I think we just know not to do it.
To some extent. Also, the other thing is the roads are in the north, they tend to treat the roads
Yeah,
beforehand. That's
part of
it. That helps. That's a huge.
And that it was sort of interesting. Have you seen? You can see these pictures of Texarkana. So Texarkana sits, as the name implies, on the Texas-Arkansas border, and Texas has no snowplows, or Texarkana has no snowplows, but Texarkana, Arkansas has snowplows. And
so half the city's plowed.
This road, that goes on the border, and like the northbound lanes are all plowed clear, and the southbound lanes are just covered in snow.
Oh no!
Which you share the name, man. Just go down the southbound lanes. Help your neighbor out.
Well, in their defense, some of that has to do with like insurance. And,
I'm sure. I'm just
tax dollars.
I'm just messing.
Yeah.
But I get it. Like, and so also some of it too. If anybody's lived in the north and has driven south, you tend to notice little things like overpasses in the south, like have these like holes in them and grids in them or whatever. But in the north, they tend to be solid walls, because in the north, when there's a snowstorm, you plow up against that wall. And in the south, if you were to plow up against that wall with the holes or the grids in them, that snow would just then drop down onto the underlying underpass and kill people. So like, even engineering wise, they tend to engineer some things like bridges and overpasses and underpasses and things like that slightly differently to accommodate for the snow plowing events. And
it's funny because like we just yesterday here in the Philadelphia area, we got, I don't know, close to a foot of snow, and I literally commenting as it's like going on, I'm like, they still haven't cleared the streets yet.
Yeah.
Like, because I'm also really transitioning quickly into a grumpy old man. Like, I'm out there like shoveling, and I'm like, look at these streets. They're still a mess.
But also, to reference our conversation from earlier, Jesse is above the fall line. I am below the fall line. Yeah. He got over a foot. I got like 4 inches. Yeah. And we live 20 minutes apart.
Yeah, it's crazy.
Yeah.
Well, I think that about wraps it up for this week.
Yeah, I'm pretty sure we angered enough people this week.
Yeah. This week, the emails will be interesting from this week. So
I hope so.
Well, thanks everyone for listening to the Premier Geology Podcast. Check us out on Twitter at GeoFlannelcast, or on Facebook, Geology Flannelcast. Go to geologyflannelcast.com. We got lots of fun stuff on our website. A lot of we'll post the links that we talk about from each episode. If you'd like to support the podcast, you can. We have some merch you can buy on geologyflannelcast.com, or we can also become a Patreon subscriber or a Patreon patron. And we have a bunch of different plans there. You can come hang out with us while we record the episodes, or check a bunch of different tiers there. Also, if you have any geology questions you'd like answered, go to geologyflannelcast.com, click on listener questions, and shoot us an email about your geology questions. Every once in a while, we'll get a bunch of these questions together, and we'll do a whole episode based on just answering them. So send them over. And I think that's about it for this week. Am I missing anything? YouTube, we got the videos up on YouTube.
Yeah,
episodes are up on YouTube.
You get to see our shiny mugs.
Oh,
yeah.
That's our faces and our coffee mugs.
Oh, this. So, so thanks a lot, everyone. And have a good week. Stay safe out there, and we'll see you guys next week. Oh, we got an interesting episode for next week. We already got this thing in the works. It'll be a fun one. So
I'm super excited because I have no idea what Chris is talking about.
I thought we talked about this. Anyways, so they don't even know. They don't even know what's happening next week. I know what's happening next week. So tune in next week. Love you guys, and we'll see you then. Bye.
See you.
Don't mess with Texas.